Hello and welcome. We are now about to begin the first part of the last discussion for the finals period for the core systems administration and maintenance. So the main topic that we will be discussing, we will be dividing it into three parts, will be about scripting. Now, one of the main advantages of using the command line environment compared to a graphical user environment, as we have studied last time, is that the command line environment has more flexibility and power in terms of executing commands. And that is because of the use of scripting. But what is scripting in the first place? When we talk about scripting, as mentioned here, this allows us to automatically execute commands that otherwise we have to execute one by one. So if without scripting, if for some instance we had to, you know, perform 100 commands at a specific time of day each day for a whole year or more, then I have to do it 100 times every day or 100 times each day. Now with scripting, I can have it executed only once, as it would execute everything that I have put into the script. And it is even possible to have it execute automatically on a specific time of day of my choosing. That is the power of scripting. But how is scripting possible? Well, we have to discuss two prior contents first, which is called the bash and the shell. The shell is what we use to interact with our computer. So if we are using a graphical user interface, the one that we manipulate on our screen, the icons, everything, would be the shell. In the terminal, the one that we have access to, the one that we put in commands in, is also called the shell. Depending on the shell, some specific commands might work on some machines. Of course, it wouldn't work on others. That's why even if Windows does have its own command line interface, CMD, which came from DOS, or which is actually DOS, this operating system, they have similarities but far more differences in terms of the commands that we can use with them. But they're both relatively shells of different nature. Bash, on the other hand, is a command language interpreter. So we can actually put in additional commands inside our scripting. Scripting commands that we could actually use, or scripting tools we could use, just like C++ shell, corn shell. Okay. So, but right now, Bash is the one that is the most commonly used type of command, okay, or command line interpreter, for that matter. Okay. Now, the shell itself is how we communicate with our operating system. So if we have the graphical user interface and then the terminal or command line terminal, both of them are actually part of the command line interface or part of the shell. So this is how we communicate, or part of the operating system that allows us to command the computer or actually interact with the computer. So this time around, we're going to use some bit of commands. So for example, we have these 4 commands here. We're going to use it. Oh, let me go ahead and log in first. I guess it slept. So we're going to use these 4 commands in our command line interface one by one. So just to show you how powerful or how good or how important knowing scripting is. We'll start with date. So it's just the date. of our current date. Then cal shows the calendar. pwd is the present working directory, which would show the present directory that we're in. So it's now at home, Kurube. And then ls would lists all of the directories and files within the local file or the present working directory. Now, imagine that if we have to do this 4 times a day, or we have to put this in every day, so that'll be 4 commands, okay, every day for each week, for each month, for within the year. So I guess it will be easy, but it'll be a bit bothersome. So imagine having 100 commands to use instead of having just 4. Now that would be harder to do. So we could use scripting so that we could execute all of these commands all at once. And that would actually execute it one by one. So we will try to show you an example of how we could use these 4 commands and shorten it into just 1 command by using scripting. In order to use scripting, we have to use a text editor, and as mentioned, we'll be using the text editor that we learned from last time, which is Vim. Okay, and I'm going to try to create our first script. Okay, so I'll just type vi, then the name of the scripting. So I'll type it as test.sh or test.shell script. And then, of course, once I press enter, it will go to our VI interface. Just have to remember when creating files, we don't want to forget that we are putting in different casings of letters, uppercase, lowercase, would have a different meaning. So be careful about that. So once we go into our test.sh created file, remember that we are in the command mode. And in order for us to start typing or putting in letters or words, we have to change into the what do you call this? Into insert mode. Okay, so we do that going to insert mode by pressing I. So we just type in the commands. Okay. Now once we type those commands, we will now be ready to save this. So how can we save this? We go back to the command interface first by pressing escape, and then we type in :x, as you would see at the bottom. So that would mean quit and save. If you want to quit but not save, we use :q. So how do we run this? We first change the permission of the file. Right now, it's not an executable file. So if you can remember from our midterm discussion, you can actually change permissions. So we have 2 or 3 distinct ways to do that. But for this instance, in order to turn this test.sh into an executable file, we would be using change mode or chmod. Okay. Then in order to change it into an executable file, so we use chmod plus x, then the name of the file, which is, of course, test.sh. Okay, so hopefully you can still remember that we could actually change permissions. So here's the one that I was mentioning. So chmod, which is change mode. We want to change it into an executable file, so I put in plus x and then the name of the file. Then when I'm done with this, okay, I press enter. Now, unfortunately, it would not show any sort of confirmation that something happened. But no news is actually good news, as if there was an error, it would actually show. So once we have changed test.sh into an executable file, it's time to actually execute the file or use the command. So in order to do this, I type in dot, then forward slash, then the name of the file, which is test.sh. Then when I press enter, you would see that it would actually show a bunch of things here, but it's actually the 4 commands being run simultaneously, or one after the other rather. So you could see that we have the name of the file, the :/test.sh. So we have the date, calendar, the present working directory, and we have our lists of files, or LS, the list of our files, directories and files. And as you could see, the one that we created a while ago was added to that list of files because test.sh was saved under our directory home/kurobue. Okay, but we have to remember that this is just scripting. Okay? We're not actually using bash yet. Okay? So we just interacted with the shell, its native commands. Then we use the text editor VI to run those commands. So we were actually able to use shell and scripting. So let's turn into your handouts so that we'll be able to include bash into our discussion. Okay. So as mentioned a while ago, we have to remember when naming files, uppercase and lowercase, or our files are case sensitive. It would actually affect our files. By the way, our discussion for today would start from string examples or using strings commands in bash. Then we're going to use variables. And then finally, we'll be using input files. Second day, we'll be using arithmetic operators up to the arithmetic operators. Then finally, we'll be using the case and looping for that matter. Okay. Anyway, going back to our main discussion. So again, we could use several letters or symbols, but we have to avoid using special characters that are often used in command lines and bash or bashes. So as much as possible, you don't want to use greater than, less than, the vertical bar, the colon, and ampersand, because that's often used. Okay? Don't forget, don't use our files are case sensitive, and we don't want to use the aforementioned characters as part of our file names. We could use the dot and underscore symbols as well. Yeah. That would be fine. But greater than, less than, vertical bar, and colon are actually not often used, as it might introduce more problems into the script or your scripting process. Okay? Okay, just a moment. Let me just fix something here before we continue. We're having a bit of technical difficulties here. Okay. Yeah. Okay. It's working. Okay. So we're going to start with using bash commands for our string examples. So bash is sort of similar to doing programming. So we can actually put in variables, do command lines, output words or output characters and strings, and actually asks or interact with the user and asks for numbers and strings and even words from the user. So we're going to use this example, hello world.sh, and explain it while we go along. So we create the shell script first using Vim. So vi, in this case, we're going to use hello world.sh. So this is a bit cliche, as with any programming language that you would experience, you'll always start, or almost always start, with hello world. Okay. So once in the vi, we have to make sure that we are in the insert mode. So we press I. Then we put in # exclamation point /bin/sh. I'll explain the function of this later. But this is required when we're going to use bash scripting. Okay. So just like in any programming languages, we could put in comments. So comments are started with the #, and then we type in any comment we want. So as with any comment, with any programming languages, it would not be part or not be executed as part of the line. Now, the first syntax we're going to learn for bash is echo. So when we talk about echo, that means we are going to actually do an output or show a series of strings, letters, words out in the terminal. So we're going to use a bit of different types of echoes for the hello world. We're going to do different things with the hello world script as well, such as putting more space, putting in symbols, encapsulating the double quotation marks on different words, or using single quotation marks, and we will see its effect. So let me just type this, and I'll explain the last part. As you can see, the echo asterisk. Just a moment. Let me just finish this. Okay. So we used asterisk here to separate hello and world. In this part, I'm going to put in hello only in the double quotation marks, and leave world. Then I'm going to put hello in single quotation marks, then leave world as well. So we're going to check its effects on the output. Then I'll do echo asterisk. What echo asterisk does is it actually lists the files and directories, just like ls. Okay? So once done, we have to make sure that we save this, and in order to save it, we have to escape the insert mode. So we press escape, or the escape key, then we type in :X, then we press enter. Then it would go back to our terminal. Then in order to execute a bash script, so we just type, we don't need to change the what do you call this, the permission. So we could just type in bash, then the name of the shell script, in this case hello world.sh, and it would show us the strings that we typed in. If you actually notice, nothing actually changed with what we have written in the echo files or after the echo, but it would actually have an effect on the properties of each of the strings or the words. In this case, for example, hello and world would have different properties, and that would have an effect if we're going to use it at a certain command that would be using those two strings. But for the function of just showing strings, that is entirely plausible or entirely acceptable. Now, hello echo asterisks, as mentioned, is similar to typing in lists. So it would actually list down the files and directories under the present working directory. Okay. So this time around, we're going to try to use variables and operators. So just like with any programming language, of course, this is a bit different. This is not really a programming language per se. It is almost similar, or pseudo programming language, but a command line interface. You could actually declare variables as well. For bash, we have three specific, in any types of shells scripts, we have three main types of variables. So any variables that we we declare inside our bash script or shell script would be called local variables, which is only usable for that specific script or shell script. Now, we also have what we call shell variables. These are special sets of variables that are by default already included into the shell script. So we do not need to declare them, and we can invoke them in any part of our shell scripts. Then we have environment variables. Environment variables are just like local variables, but with a much wider application or much wider acceptance, because local variables can only be used at the present shell script. But if we put in a different process or a child process, we won't be able to use that local variable. But with environment variables, we could use it into a child process of the shell. The child process of the shell is another process that we can create. So let's try to create the example or recreate the example that we have here from your handouts and try to explain its functions. So as always, I'm going to create the shell script variable.sh. I'm going to the VI, have to press the I key to go from command mode to insert mode. So I'm going to type in the example here and explain. So as always, we have the sharp sign, then the exclamation point. We call that as the shebang. Okay? Sharp. It actually is called shabang before, sharp and then bang for the exclamation point, but it was changed to shebang. I guess, I don't know, it's alluding to the song of Ricky Martin. Yeah. Anyway, so we need to put this in. What's that bin-sh? The slash bin slash sh, actually it is actually pointing to where the bash command or process is located. So we are declaring a local variable here. In this case, the variables that we're going to use here would include strings. So in this case, I'm going to put in the string welcome enclosed in double quotation marks as part of the word greeting. Then we have user. In this case, we're going to invoke a different variable, which is the command who am I. Who am I is actually a command that could be used in inside the command line interface of Linux, and its output would be the name of the current working or current login or user of the login user. So in this case, it would output kurubwe, which is my login username. But instead, it would not actually put in the command. It would actually put in the output. Then, we am creating a local variable day. And then, I'm going to have it store the date command. If you can remember from the date a while ago, it would show you the date, the time. Okay? So I just want to look at the day, which is Monday. So that's why I added plus percentage and then the capital A. So by doing this, it would only show the day. It would not include the date and the time. Now, because I declared this in our script, that would mean that these are all local variables. The who am I and date are native commands inside of Linux, inside the terminal that we were using. So we're going to use those local variables as part of our echo syntax. Okay? So I'm going to put in $greeting. So by the way, using the $sign is the way to invoke variables into our scripts. So that's why we don't want to use $sign as part of our file name. So $greeting means it's calling the variable greeting, which contains the string welcome. So once you execute this, you'll see the $greeting will change to welcome. So $greeting back, $user, I'm invoking the contents of the variable user, which contains my username. The exclamation point won't be part of the variable as $user has been declared at the top. So I want to invoke the day today without the date and the time. So I put in today is $day. So what would happen is the local variable day would show us the would be part of the string, the first echo. Then I'm invoking a different echo at the bottom, which is try to have an output of the current shell version. So echo colon, or not colon, sorry, double quotation mark, bash shell version is colon dollar bash version. So if you notice, we did not declare that on the top. We don't have a variable bash version because bash version is actually a type of shell variable. So because it is already included, we already put that in. We don't have to declare it. As always, we save. So we go to the escape and colon X. Then we type in bash variable.sh to execute the file. So you'll notice, welcome back Rube, which actually shows the name, which is the command who am I. Then today is Monday. So instead of showing us the whole Monday, as you would see, let me check. We had one of the date. Here we go. So Monday, the date and the time. So it actually removed the date and the time and just included the day. And it actually completed the whole word Monday. And then the bash shell version will just show the release version of this bash command, which is 5.0.11 open and close parenthesis 1. Yeah. So the one that you declared were the local variables as mentioned. So we had 3 of that: the greeting, the user, and the day. And the bash version would be our environment variables. So we actually have other special variables that we have to be careful of. As much as possible, we want to have our variables descriptive and not contain one letter, because you might be using one of the special variables, and by no means these are all the special variables. There are other special variables not included here, which is usually a single character or a single letter again. So we don't want to accidentally use that, so we use something descriptive. Each special variable has its own special description. We won't be going into details of the contents of the description of this. We're going to just use this or explain this when we use it, or if we're going to use it, or once we use it in the future parts of our discussion. Okay. So let's now go into an input example. In this case, we're going to interact with the user. So we're going to ask a input from the user and use that input and store it into a variable. Then use the input of the user as part of a what do you call this? As part of a string that we're going to output in the terminal. So as always, we create a shell file, a shell script, vi introduction.sh. We put in our shebang, okay, the colon exclamation point, and then the bin-sh. You just have to remember that this is always included as part of our shell script. Then we type in, we won't be typing in the comments. We already I've already explained a while ago what the comment is for. So anything after a sharp sign, except for the shebang, would not be executed. Okay, so I'll be going directly to the command. So I'll be putting in the, let me just check here, just a moment, here, okay, it's working. Echo, hello, who am I talking to? Okay. So of course, as mentioned a while ago, as we learned a while ago, it's used as an output for our command, or for our script, or string rather. And then we're going to use the syntax read when we're going to ask an input from the user. Then we're going to declare a variable as part of the read in which that input will be stored. In this case, we're going to declare the variable as var name. Okay, we don't have to declare it at the top. Okay, we could do it right here. So read var name, and automatically it would store it in the variable var name. Then we're going to use var name into this script. So it's nice to meet you, then $var name. So whatever they put in the input would be part of this specific string. So let me go ahead and go back and save this, :x, escape, :x, and let's see. So bash introduction.sh. Once I press enter, it won't go through the third command as it be waiting for an input. So hello, I'm talking to, let me just put in my name, Jlold. When I press enter, it would say, it's nice to meet you, Jlold. When I type in Jlold, it actually put it in the var name that we have declared a while ago. And then the var name now contains Jlold. That once we invoke the variable var name into the string, it, as you can see, it was now included into the string. Okay. Anyway, that would actually end our discussion for today. We'll go into arithmetic operators and such